Hi everyone, my name is Emanuele Maso. First of all, thank you for being here. I know it's 5 p.m. on Saturday. Talking about cryptography in English could not be the best thing to do, I know. But I promise this will be easy to understand, easier to understand. I will not talk too much about theory. So, yes, who am I? I'm a mobile developer at Bitrock. I work mainly on Android development. My major experience is there, but I also work on iOS development, Flutter, and Kotlin multi-platform. So yeah, let's start talking about cryptography. What is cryptography? Cryptography is the art of protecting information by ensuring that it can only be read by those for whom it is intended. That means we don't want to be attacked, basically. We want to protect users' data without being attacked from someone. When we talk about cryptography on Android, there are a couple of use cases. The most used one is about protecting sensitive data of the user that we want to keep it private, and we want to store it on the device, on the user's device. But also we can apply cryptography when we want to communicate with some external actors. Could be machines that are working with local intranet, I don't know, something that we want to use a cryptographic manner to communicate with something outside the device. And in general, we want to prevent attacks for the user and on our apps. So as I said, on this talk, I will not talk about theory too much. I'm a mobile developer. There are a lot of interesting stuff on internet that can explain you better the algorithms and the theory behind them, and I encourage you to study it. But of course, we need some basic concepts in order to align everyone, and then use algorithms and cryptography for our necessities as tools for our goal. So some basic concepts. Symmetric key algorithms. These are some kind of algorithms that share a secret key that is used to either encryption and decryption phases. So starting, for example, with a plain text, which could be a string, we generate a secret key and we use it with an encryption for the encryption by using an algorithm. After later we will see which algorithm can we use. With the encryption phase, then we move to we obtain a ciphertext, and with the same key, we can use the algorithm to get the original text back from the ciphertext. And this is called symmetric encryption because we are sharing the same key for either encryption and decryption. Then we have asymmetric key algorithms, which are using a pair of keys. One, which is the public key, is used to encrypt our data, and then one is the secret key or private key, which is used for the decryption phase. When we have a ciphertext, we obtain the plain text with our secret data. So, for as an example, if someone wants to send me a message, I give to this person my public key that I generate, and this person can encrypt some data and send it to me by using this public key. Then only I will be able to decrypt this data by using my secret key, which of course I should not share. So when we're talking about Android, someone can ask me, okay, aren't there encrypted share preferences for that? And the answer is no, because and the Android team deprecated recently the encrypted share preferences library, but this is not the only thing to mention, because of course with encrypted share preferences we are looking at only one thing about cryptography: storing some data with an implementation of the shared preferences, which is, by the way, deprecated as well. Plus this, and of course we want also to have more possibilities with the use cases that I mentioned. Also, this library I never get along with because there's still a couple of bugs. there are a lot of blocking bugs. I added some of them on the last slides, and yeah, I don't think that we will fix this kind of issues since they are deprecating the library. So let's say that I never slept well with this library implemented. So let's try to understand a little bit deeper what we can do, what is doing something like this library, and let's see what we really can do and what are our possibilities here. So first of all, I would like to share with you my demo app, which is just a small example, small app with some examples that I prepared for this talk, and then we will see the code behind that and just comment that. So as you can see, this is the app. It's not a talk about UI and UX, as you can see, but it's fine. I mean, it's easier to understand. Also, if you want to look at the code, it's on GitHub. It's easier to understand. This is just a normal MVVM app with Compose. And as you can see, there are 4 tabs on the bottom bar. First tab is telling us, okay, symmetric encrypt and decrypt. Let's don't think about the first selector there. We can input a text, tap encrypt, and okay, I have a result which should be encrypted. Then I copy it to the clipboard, paste it again, decrypt, and I have my original text back. Second tab is really similar, but I have added a way to store this kind of this informations, this ciphertext. So I always encrypting it with the same algorithm, symmetric keys algorithm, and I can store the result on data store, which is the the next step after the shared preferences, just to store easy data like a string. And here we have an example of that. And on the first input text, you can see that I'm showing what is stored inside the data store. Third tab, always symmetric encryption, but here we are adding the authentication method. So if I try to encrypt something, here you cannot show it, but I can show it here. There is an authentication method requested. So the app is asking me to authenticate myself as a user. I can put my fingerprint, and then I have the result. So I can encrypt my data. And of course, there is the reverse. I can decrypt it. It's asking me some authentication method, and then I have the result. Last tab, asymmetric encryption. Here I have my personal public key, which I can copy to the clipboard and share it with someone. I have an input text. I can input a text and use some public keys. Here I have mine, but I can also input one of someone else. Encrypt a text. I have a ciphertext as a result. I can copy it to the clipboard, and if I paste it here and tap decrypt, it will use my private key for the decryption phase. Okay, and this is the demo. First thing that we want to know is how we store these keys, because on this app, in order to make the encryption and decryption, I need to generate these keys. And the most important thing when we talk about cryptography is not about the algorithm, because it depends on what you want to achieve and what are your needs. You decide the algorithm. But the most important thing is how you are storing your keys, because the keys are the real secrets here. So for Android, we have the Android key store, which is a cryptographic component of Android that provides a secure storage, like a cage for our keys. And here we are not storing our encrypted text or something else. No, we can only store keys generated by the Android system. And the Android key store is like an implementation that could be just software or also hardware on our device. Last devices, like from Pixel 6, is implementing some security hardware systems, some security hardware components in order to achieve higher level of security. And we are talking about the Trusted Execution Environment, TEE, which is like a module on, or better, like a component on our CPUs, which is dedicated to performing or storing information securely. And then also we have a separated module that we can implement as a vendor, which is the Secure Element, SE. And most of the time now you will see both of them implemented. There are no real standards there. The vendors are implementing this key store following some guidelines, but they are working on generating a real standard for that. But anyway, the key thing here is that we want to achieve a higher level of securities by raising like some walls hardware that will be harder for the attackers to break. The Android key store will not let attackers to get the keys from app to app. Of course, talking about no root devices. But I cannot even if I'm not a root user, I cannot impersonificate some other app and get the keys that are generated from that app. So there are a couple of security systems implemented that at the moment are letting us storing securely these kind of keys that we use for the encryption and decryption. So if we look at our code here, on this repo, as I said, there is just a normal MVVM app, but with some classes that is basically doing all the job that we are interested in. The first class is Symmetric Crypto Manager. Here I split them in order to be more, let's say, be more clear during this talk. And our entry points here are the encryption and decryption method. So when we want to encrypt something, can you see? Is it bigger enough? I hope so. Yeah. When we want to encrypt something, we need, first of all, a key store instance, which is generated here. Let me see it. Once we get our key store instance, then what we need to do is to generate a cipher. What is a cipher? A cipher is an algorithm that we can implement and use to perform our operations of encryption and decryption. So by generating a cipher, by initializing a cipher, we need to pass the algorithm that we want to use. In this case, for the symmetric encryption, I decided to use AES GCM with no padding, which at the moment should be the best option for the symmetric encryption on Android. You will see a lot of examples also on internet with CBC, which could not be the best option at the moment. GCM is faster, and there are different things that are better with this algorithm. I'll let you discover what on some theory on internet. But if you want, there is also an implementation of CBC, because maybe you have to talk with some machines with legacy implementations and you need to use CBC for, and you're obligated to use that. So here I defined a constant, which is a transformation, which is a composition of the algorithm AES, current block mode, which is in this case GCM, and the current padding. In this case, GCM padding is no padding because it's not needed for this algorithm. And when we instantiate the encrypt cipher, which is needed to perform the encryption of our plain text, we need the cipher like that. Basically, we just explain what we want to do and get a key by explaining what is the algorithm that we want to implement. So here we are the algorithm, and here we get the key. Generating the key is a topic, of course, and this is the most important thing. We are using our key store to get the key if it's already there by using an alias. When we generate keys, we use an alias to name them, and we can use this alias to retrieve them when we want. Or we can also generate a new key. For example, like here. You can generate n keys for your app or just use the same. In this case, I'm using the same, and basically here we are using Java X Crypto and nothing special at all. And we are specifying the alias key that we want, the purpose of our key, which is encrypt and decrypt, a key size, the block mode, and the padding that we already talked about. And we can generate the key. So we instantiate our cipher here, and then we are ready to perform the encryption method by calling this doFinal and passing, like, for example, starting from a string, you can get to the byte array, and calling the doFinal will get you your ciphertext. Then, for simplicity, I put this ciphertext on a base64, and here comes our selector that I told you in the first place, because here you have a selector, append, byte array. These are just two ways on how I decided to take together the initialization vector and the ciphertext, because for this kind of algorithms, like GCM and CBC, you need to store also the initialization vector, which is a random data vector, which is generated in this case by the cipher itself when it is instantiated. Now, it's really important to have a different initialization vector each time you do a new message, you perform a new encryption, in order to avoid statistical attacks and other kind of attacks, especially when you have a lot of encrypted data stored on your device. So you need to find a way to store the initialization vector that you use for this particular encryption and the ciphertext. The initialization vector will be used on the decryption phase. So, for example, here I use the append mode, which is a really silly way to store this data on a single string, because I have the initialization vector that we call IV encoded on a base64 string with a separator, which is just 3 pipes in this case, and the ciphertext itself. Now I have my ciphertext and my initialization vector, and from here I can store it like whatever I like. For example, talking about storing this this encrypted data on our devices, we can choose to save it on a data store, on a shared preference, also to save this ciphertext on a database with room, and then use a different column for the initialization vector. No, it's not a problem. You can do whatever you want. And that's why I also built up a new method that is just using a byte array instead of a string to couple these two informations that I need to store. So now I have my encrypted text. I want to do the reverse. So starting from an encrypted text, which is a string, and by the way, now you can see what is happening here, because if I try to encrypt a text with append mode, you will see, now you will recognize 3 pipes here that I don't have if I do the byte array mode. Okay, this is just a way to express this, but you can do whatever you want. So we come to the second tab, where I actually just stored these informations, these informations on a data store, but again, you can do whatever you want. And now you have the decryption method, which, starting from a string, requires to get a byte array or a string back. So the decrypt from, let's see, the append mode, which is the easier, we are starting from IV and a ciphertext, and we need to split these two informations by looking at the separator that I added in the first place. Split this together, these two informations, and I have my IV and ciphertext decoded from a base 64. Now that I have these kind of informations, I can initialize my decrypt cipher and passing the initialization vector that I got. Now here, it depends on what you're using. If you're using GCM, it's a different initialization because the GCM parameter needs also the tag length, which, let's say, it helps you to get the authentication also of what you are trying to decode. So basically, you are sure that the data was not changed by some attacker, and the user that authenticated that message in the first place is the real one. Is not changed. Is not attacked by someone. But here, basically, we are initializing the cipher by explaining that I want the decrypt mode, getting the key, which is, by the way, the same because I'm using only one key, so it will look for the alias of the key that I generated in the first place, and then passing this parameter spec. Then, then by calling again the doFinal method, I can pass my ciphertext, which is this one, and I have my plain text. Then, of course, now I want to put it on a string, and you have the result. Now, some considerations about that. Of course, when you generate a key, there are things to keep in mind. The first one is that the keys that you generate on your device are lost if you delete the data on that device, and are lost if the user is deleting the app. So it's really important, if you want to store this kind of information, to tell the user to communicate with the user through UI and UX in order to be really sure that he knows what he's doing. Because if you lose the key, the user will not get his data back anymore. So it's really important. And then, of course, you need to explain to the cipher what you want to do. In this case, we use GCM, but there are a couple of the algorithms that you can use. And also, now we come to the third tab, which is authentication. For the authentication, we are just using two flags on the generation of the key to explain during the generation that we want the user authenticated before using the key. And now we are doing that by using these two flags. Okay, the first one is telling us, okay, I need authentication of the user before doing something with this key. And the second one is the most important because it's really dangerous. If you leave it without expressing some preference, the default value is true for this flag, set invalidate biometric enrollment. And by leaving it to true, or by setting it to true, you are telling the key generator to invalidate the key anytime that the user is changing something on his authentication methods on his device. So if I'm the user and I'm just adding a new fingerprint to my authentication method, the key is invalidated and you will not restore your data anymore. So putting this as a default by true is not that good in my opinion, but it's really a really restrictive way of seeing things. Of course, you can put it to false, and what it's doing is invalidating the key only when something a little bit further is changing on the authentication method. If I add a fingerprint, it will not invalidate the key, but if I remove some authentication method, it will invalidate it. So again, it's restrictive. It's important to communicate to the user what we are doing, because it will be really a pain then to understand why the user lost his data and he's calling you, what are you doing, where is my data? He will never tell you that he changed something on his authentication systems. He will never maybe even remember that, so pay attention to that. And if we look at our class, which is a different class for that, you can see that here I'm basically doing some checks based on the SDK, because thanks Android. And then I'm setting these two flags here. And then I can also specify the authentication parameter, like I want a biometric strong authentication, so you can use device credential or not, something like that. The main difference here is also that you need to pass the cipher up to the UI, because in order to show the biometric configuration and ask the fingerprint of the biometric itself with the system library, you need to pass the cipher up to the UI and then use that library for biometric to unlock our cipher. So it's just a matter to pass the cipher also to the UI. Another thing to mention is that the key generated with these flags is not related to a specific fingerprint or biometric configuration, because it's just a blocker before using that key. But it's not something that, okay, I generate the key and it will use my fingerprint with my SHA for something. It's nothing like that. It's just a block before using that key. If the authentication is invalid, the key will not be used by the system and you will not be able to restore your data. That's it. Okay. Last tab was talking about the asymmetric encryption, and I used RSA in that case. Here I have the example on a different crypto manager class, and yeah, there are a couple of differences here, of course. The first thing is always instantiating a key store instance, and then we have always the encrypt string and decrypt string method, but here we want to use a public key which could not be our public key. So we are getting this public key as a string from outside, from an input of the user. And the first thing to do is to transform this string, which we know that is a public key, into a protocol that the library can understand. So I have this method here, string to public key, that starting from a string, it returns a public key, which is a class of Java security. And yeah, we just need to specify some specs and the algorithm that we are using, which is, in this case, the RSA algorithm. Once we have the public key, we can use the cipher. We can retrieve our cipher. We can instantiate our cipher with the public key that we want to use, specifying the transformation, which in this case is just the algorithm. And we can initialize our cipher. Here also, apart from the public key, I'm specifying some specifications, which is strictly related to the RSA algorithm and should represent the standards of the moment, let's say, and is making RSA a little bit more secure with some hashes and masks. So once you have the encrypt cipher, you can always call the doFinal method and have your ciphertext. If you want to do the decryption, you start from an encrypted string, decoded from basis 64 because it's the default that I had here. And to obtain the plain text, I need to retrieve our decrypt cipher. Getting the decrypt cipher is always passing the transformation and initialization the cipher for the decryption, but here I'm retrieving my private key. So I'm looking for the pair of keys that I generated before when I shared my public key to someone else, for example. I'm retrieving that pair of keys like this, and always looking for an alias. And I'm getting this pair of keys, the private one and the public key. And of course, I'm not showing it anywhere else. I'm just using the private key that I generated in the first place in order to perform the decryption method. Okay. It's Saturday, so I understand. It's not easy to understand, and of course, it always requires a little bit more of theory behind. So I encourage you to study it because there are really good YouTube videos and articles out there about encryption theory. And yeah, here's a small recap of what we talked about. Basic concept, what is a symmetric and asymmetric algorithm. Show you the demo, what is the Android key store, and what security hardware we can use for that, and the vendors are using. The key generation for asymmetric and symmetric keys, and the cipher, the initialization vector, why it is important to use an initialization vector different each time, and the encryption and decryption that we used. Something that maybe it was not so clear in the first place that I can show you is that here, when I instantiate the encrypt cipher, I'm calling a new instantiation each time because when you do the initialization of the cipher, the initialization vector is refreshed. And how it is created? By using the secure random by Java. So that's why I'm recalling it each time, this method, and not instantiate it once and then using it, like for example for the key store. And that's, of course, it's really important. Here you have some links to deep dive and to learn a little bit more. There are some theories and also the issue that I mentioned about the encrypted share preference. Here's the GitHub repo. You can fork it, look at it, and commenting it. And grazie. If you want to help me with my talks and help me become a better speaker, here's a really small survey that you can fill. Thank you so much.